Let's take a look at section 6.6, Rational Equations and Problem Solving. We begin this lesson by first learning how to solve equations for a specified variable. So we're going to be dealing with things like formulas that they're asking us to rearrange to solve for a particular letter. This becomes very helpful at times when we are solving word problems. Here are the steps that we're going to follow. As you read through them, you'll notice they are very similar to the steps that we use for solving any algebraic equation. The final step, number 5, is the one that is slightly different because we're solving for a particular letter and not just the only letter or variable in a problem. Step number 1, if there are any fractions, we're going to clear them out by multiplying by the LCD, the lowest common denominator. Step 2, if there's any parentheses, we're going to get rid of those using the distributive property. Step 3, we're going to combine like terms, which are the terms that have the same variable raised to the same power. We're going to combine their numerical coefficients by adding or subtracting. Step number 4, we're going to use the addition property, which means that we are going to add or subtract the same quantity from both sides of the equation. Now what we're going to be trying to achieve in step 4 is to get all the terms that contain the specified variable on one side and all the other terms that do not contain that specific variable on the other side. Finally, step number 5 is usually when we use the multiplication property to either multiply or divide whatever is necessary to isolate the variable. And we will do that. However, also keep in mind that we might use the distributive property in reverse. In other words, we might factor out the specific variable we're looking for and then follow up by dividing both sides by what is attached to it so that we can isolate it. Let's take a look at this example, problem number 2 from your textbook. This is the volume formula. V equals 1/3 pi RH, V equals 1/3 pi R squared times H. They're asking us to solve for H. So that means we want to get the H by itself on this side. So let's begin. It has a fraction in it. Let's get rid of that fraction by multiplying both sides by the common denominator, which is 3. So here I multiply both sides by 3. What happens is 3 times 1/3 cancels and gives me just 1. So I bring down the pi R squared H. Then I can isolate the value H, or the variable H, by dividing both sides by pi R squared. So here we have solved for the specific variable that they wanted. We've isolated it on one side, so H is equal to 3 times the volume divided by pi R squared. Taking a look at this formula, which is used in electronics, we're solving for capital R. Now notice you have R, R sub 1, and R sub 2. We are solving for just R. Well, to begin, it's an equation that has fractions in it, so once again we're going to multiply by the LCD, which in this case would be all 3 R's multiplied together. So we multiply both sides of the equation by that. On the right-hand side, we'd need to distribute it so both terms are multiplied by the LCD. In green, I'm showing you what is canceled by multiplication. The R's are canceled, and so you bring down R sub 1, R sub 2. Remember to write these subscript numbers. Here, the R sub 1's cancel, so we bring down R, R sub 2. Here, the R sub 2's cancel, so we bring down R, R sub 1. Now remember, we were trying to get the letter R by itself. Right now I have it together on one side of the equation, but it's not by itself. So how can I pull it away from the R sub 2, R sub 1? I can do so by factoring it out as a GCF. So when I do that, I can now divide both sides by R sub 2 plus R sub 1, causing me to have the specific variable of R isolated, everything else on the other side. In this example, that is a formula that's used in the field of optics. Once again, it has a fraction in it, so we're going to get rid of those fractions by multiplying both sides by the common denominator, which is the f sub 1 plus f sub 2. So we multiply both sides by it. It cancels out on the right side, as you see here in green. So I just bring down f sub 1, f sub 2. On the right hand side, I'm going to distribute to get rid of the parentheses, and this is what we end up with. Now remember, we're trying to get the f sub 2 by itself. Well, I have one term with it on the right side and one term with it on the left. So what I'm going to do is move this term over to the right hand side by subtracting it from both sides. This gives me this line. Once I have it over here on the right, I can't actually subtract it because they're not like terms, but what I can do to get the f sub 2 by itself is factor it out as a GCF. So remember in that step, the fifth step on the first page, we talked about remembering to factor out the letter you're looking for if necessary. So we did that here, factoring out f sub 2 from there and from there, then divide both sides by what's inside the parentheses, and you have now have your variable by itself equal to all of this. A very popular formula we use is the distance formula, and we usually have it in the form d equals RT. But every once in a while we'll need to actually have it solved for t, which is time. So you would divide both sides by r, the r's would cancel here, and you would end up with time is equal to distance divided by rate. And so we're going to be using the formula in that format at different times. Let's take a look now at the second type of situation that you're going to see in this section. So the first type is solving for a specific variable. The second type of problem in this section involves proportions. Proportions are the equality of two rates. So A over B is equivalent to C over D. The ratio A to B is equivalent to the ratio C to D. So a lot of key phrases that are used in this type of problem are at this rate. At this rate, this is going on. So what would happen if this was what you had? And so we write the first ratio and then we set it equal to the second one that is presented. Now when you have a proportion, you can find the cross products and they should be equal to each other. So A times D should be equal to B times C. For example, in the cooking rice, you usually have 1 cup of rice to 2 cups of water. So if I wanted to do 3 times the recipe, I would use 3 cups of rice. How many cups of water would I use? Well, again, we could do the cross products here and say that x, 1 times x is equal to 2 times 3, which is 6. So you would need 6 cups of water to make that happen. All right, our first problem, if you take a look at it, we're talking about a camel that can drink 15 gallons of water in 10 minutes. That is the first rate that they give us. So notice here 15 to 10 gallons to minutes. At this rate, how much water can the camel drink in 3 minutes? So notice the 3 represents minutes, so I put it in the same location that minutes was in the first ratio. What we're looking for is how many gallons of water the camel can drink. So x to 3 is equivalent to the 15 to 10. When setting up proportions, you need to be consistent to make sure that you're putting the same units of measurement on top and on bottom. So gallons on top, minutes on bottom, gallons on top, minutes on bottom. All right, another way we could set this up would be to put minutes over minutes, gallons over gallons. We just need to make sure that we're associating the correct minutes on top here with the correct gallons over here, correct minutes here with the correct gallons down here. So anyway, finding the cross products, we would multiply across here 3 times 15 and set it equal to 10 times x. When you solve for x, you end up with 4.5 gallons is what the camel could drink in 3 minutes. The next type of problem we're going to look at is a work problem. We've seen these earlier in the semester. This is the way I like to set them up. Fraction plus fraction equal 1 job done, with the time together that they work on top of both fractions, and one person's individual rate here, the second person or machine's individual rate here. The book sets it up like this. 1 over individual rate plus 1 over the second individual rate equals 1 over time together. Same equation, just solved a little differently or set up a little differently. So these problems usually have people or machines working together to get a job done. So here we have an experienced roofer who can roof a house in 26 hours. A beginning roofer needs 39. So what we have here is time together, which is the unknown, over the first person's rate of 26 plus time together over the second person's rate of 39 equal 1 job done. So we're looking for how long it takes the two of them to get the job completed. We multiply by the LCD. We're looking for an LCD of 26 and 39. One of the ways you can find that is first factor each number. So 26 is 2 times 13, 39 is 3 times 13. And then remember, the LCD is each unique factor to the highest power. So we're going to take 2, we're going to take 13, and we're going to take 3, and we're going to multiply them all together. We did not have to include both 13s because they were both just to the first power. We just take the factor to the highest power it appears. When you multiply that all together, that would represent our LCD. So notice I multiplied both sides of the equation by that LCD. Then in green, I'm showing you what canceled. The 2's, the 13, so you end up with 3x. Here, the 3 and the 13 cancel, you bring down a 2x. Here, nothing cancels, you multiply it all out, you get 78. 5x equals 78. When you divide, you end up with 15.6 hours is how long it would take them working together. Approximately half the time of one of the people. All right, let's take a look at this next example and see if we can identify what kind of a problem it is. 12 out of the 20 top movies were rated PG-13 at this rate. Oh, there's those key words. This is a proportion problem. How many movies with 692 releases would you predict will be PG-13? And notice they're telling us how to round our final answer to the nearest whole number. So we start off with the first rate as is, 12 to 20. Equals, we now need to figure out what is missing and what do we have. 692 releases, that's the total, so we put that down here, we're total, 692. We're trying to find how many of those are PG-13, so the PG-13 goes on top, and that's our unknown. Cross products, 12 times 692, 20 times x, you solve for x, and you end up with 415.2. When we round this to the nearest whole number, we always look at the place value to the right of what we're rounding to. Since this is less than 5, we would leave this at 415. We're rounding down to 415. So 415 movies approximately will be PG-13 movies out of the 692. When you take a look at this next problem, we have a company who has an experienced surveyor who can do the job in 4 hours, an apprentice who needs 5 hours. How long will it take them working together? So this is a work problem. So we have time together over the first person's rate, time together over the second person's rate equal 1 job done. The common denominator to get rid of these fractions would be 20. So we multiply both sides of the equation by 20. Here the 4 and the 20 would cancel, giving us a 5. So we have, that's how we're ending up with the 5x here. And here the 5 would cancel with the 20, leaving a 4. So that's how we get the 4x there. And then 20 times 1 is 20. Always remember to multiply both sides by your LCD. Solving here for x, we end up with 20 over 9. Or as a mixed fraction, you would divide 20 by 9. It goes in there 2 times, which is 18. You'd have a remainder of 2 over 9. So we could write our answer as a mixed number, 2 and 2/9. Be mindful that next to the answer box in My Math Lab, they usually have a set of parentheses where they've given you a description of how they would like the answer turned in. So be mindful to take a look at that to see if they're asking for a decimal or a fraction or a mixed number.